On this computer. Okay, so let's jump into things, and we're gonna talk tonight about how to do fractions kind of by hand. Okay, and this is a review, but for some of you, you might have been placed in this class, and you're going, it's been a long time. So let me just jump into things and help you guys out. Everything related to this fraction, um, doing fractions. Okay. So having said all that, let me see, can I make this a little bit larger? That's a tiny bit bigger. All right, take a moment and just write the fractions down on your paper, and I will, I will kind of explain these in a moment. I've been teaching fractions, just so you know, for the college for like a number of years now, and yeah, I'm just so used to doing it face to face that online is just different. But we're going to make this work, okay? Um, so, like I was saying, the nice thing about a recording is that you have the opportunity to listen to it, stop it, practice, play, rewind and play it as much as you need to. Okay, so hopefully this will be helpful for you as a review. So. All right, so one thing you might want to write down here is that there's a rule for adding and subtracting fractions, okay? And so I'm going to write this rule down here at the bottom is you have to get the same denominator, okay? And that is the rule. Denominator, okay. You have to have the same denominator. This is an O here, before you can add or subtract, okay? It's kind of important to just kind of like really write that down and remember that, okay, when I'm adding and subtracting fractions, I can't do it until I get the same denominator, okay? And now once I get the same denominator, then I can add and subtract them. All right, so that's kind of the rule for adding and subtracting fractions. Now, additionally, it's important to know that, well, let's just jump in and look at an example here. I've got 4/5 plus 3/5, okay? In this case, I have the same denominator. I've got a 5 and a 5, okay? So then I'm ready to add as soon as I have the same denominator. So I'm going to bring down that denominator, okay? And I'm going to add my numerators. So if I circle my numerators with, let's say, red here, okay, here's my numerators. I'm going to add those up, and I get a 7 here, okay? So what I have here is 7 over 5. And you may recall that that's what's called an improper fraction, because the numerator is greater than the denominator. And so we turn a improper fraction into a proper or mixed fraction by dividing the numerator into the denominator. We just ask ourselves this question: how many times does 5 go into 7? It goes into it one time. And how much is left over? There's 2 left over. That now is my new numerator. And then I just bring the 5 over, okay? And so 7/5 is the same as 1 and 2/5, okay? Just so you know that. Um, and so, hello, welcome. Be sure to turn your microphone off and your camera off, or your microphone if you just joined us, for a few minutes here. Let's just do a couple more here. Well, actually, let me just write one over here on the screen here. See if I can. Let me just reduce this. If I had, let's say I had 1/4 plus 2/4, okay? I think you guys could do that now, okay? At this point, you guys could probably do that because the rule says you have to have the same denominator, which I now have. So I bring it down, and then I just add my numerators. 2 plus 1 is 3, and so the answer would be 3/4. That's a nice, simple example. Um, of adding some fractions that have the same denominator. But the question comes up, what do we do with number 2 here, where we don't have the same denominator? Okay, now what do I do? Okay, and I'm going to walk you through this. And again, you can listen to the recordings, and I have them also in my Canvas class. Here's what I want you all to do. I want you to write an equal sign here. And then I want you to look at those two denominators here. I've got 5 and I've got 4. And here's what we're going to ask ourselves. What is the lowest, it's called the lowest common denominator, or some people call it the lowest common multiple. So I'll put an LCM here, okay? What is the lowest common number that both 5 and 4 multiply into cleanly? Okay, that means it's exactly whatever that number is, okay? I happen to know that, well, 4 doesn't go into 5. If I double 5 to 10, 4 doesn't go into 10. If I triple it, 5 times 3 is 15. 4 doesn't go into 15 cleanly, but 4 goes into 20 and so does 5. So 20 is my lowest common multiplier or lowest common denominator now, okay? Now, so that's what we write. We just write a 20 next to it. It equals something over 20, okay? Like I did. Now we've got, let me start at the bottom here. 3/4 equals something over 20. Here's how I think out loud. I ask myself, how did the 4, what did I multiply 4 by to get to 20? I must have multiplied it by 5. And so if I want to write there real small here, 5, okay, I multiply that by 5 to get to 20. So I have to do the same exact thing to the numerator. Whatever I did to the bottom, I got to do to the top number. So 3 times 5 is 15, okay? All right, let's go to the top one fraction here. 2/5 equals something over 20. I'm asking myself this question. What did I multiply 5 by to make it become 20? I must have multiplied this times 4 here, okay? So I'm writing kind of small. So whatever I did to the bottom, the denominator, I got to do to the numerator, the top. 2 times 4 is 8. All right. Now I can go back to, just like I did in number 1 here, I've got the same denominator. I've got 20 here. So I'll bring down my 20. I will add my 15 and 8, 18, 19, 20, that's 23, okay? By the way I did that is I looked at 15 and 8. If you're wondering, how did I do that so fast? I decided to replace the 5 here and make it 18. And then I added 5 to that really fast, okay? That's how I did it real fast. Now, look at our answer here, 23 over 20. Hopefully you'll recognize that the denominator is greater than the numerator. So that's called an improper fraction, if you want to write that down, okay? Improper. Proper, okay. All right. And just so you have the definition of that, it's where you have, or an example is when you have the top number on top is bigger than the number on bottom. All right. We're going to change our improper fraction to mixed by asking how many times does 20 go into 23? It goes 1 time. How many are left over? 3. That's my numerator. And I just bring over the 20. So I'll just draw a little arrow over here, okay? And I always ask myself visually one last time, can I reduce this anymore? No. Okay. All right, let's do another one. I've got 5/6 plus 2/5 plus 4/15. This is a 4 here in case it looks a little funny here. That's better. All right, so you're trying to find the lowest common denominator or the common thing that all 6, 5, and 15 all go into, okay? Well, here's the way my brain works. I look at for me personally, I just look at the biggest number, the biggest of the 3 denominators, 15. And I ask myself, do all 3 of them go cleanly into it? Because 15 goes into itself cleanly once, okay? 5 goes into 15 cleanly 3 times, but 6 does not go into 15 cleanly, okay? So I double that biggest number to 30, and all of those numbers go into 30. So 30 is what some people call my lowest common denominator or lowest common multiple. Okay, so watch how I'm writing this, and I want you to write this in your notes so it looks the same, because it'll help you to figure out what to do next. If you have this equal sign here like this, okay? All right, I'll start at the bottom here. I asked myself, how did the 15, what did I multiply 15 by to turn it into a 30? It's times 2. So that's the same thing I'm going to do to the top number. And this now becomes 8. What did I multiply 5 by to get it to 30? Times 6. So I got to do the same to the top, and I get 12. What am I multiplying 6 by to get it to 30? Times 5. And therefore, I've got to do the same exact thing to the top. Okay. By the way, let me point something out to you. You see how I'm writing all these times right here each time? When you start getting the hang of it, you don't have to write all that out. To speed things up, this is how I would do it. I would go 5 times 2 is 30, so 4 times 2 is 8. I would just do it all in my head. 5 times 6 is 30, so 6 times 2 is 12. I'm just doing it in my head and writing the answers up here. Okay. Now I have 3 fractions that all have the same denominator, 30. 25 over 30, 12 over 30, 8 over 30. I can now add, okay? So I'm going to bring down my 30. I'm going to add 8 plus 12 is 20, plus 25 is 45, okay? That again is an improper fraction because 30 goes into it 1 time. How many are left over? 15, because the difference between 15 and 30 is 30 and 45. The difference between them is 15. If you subtracted them, you'd get a 15, okay? Now, this is a good example right here, this answer here, why I always ask myself one last question. Can I reduce that? Did I do that right? Yep, I did. I'm looking at 15 over 30 and going, oh yeah, 5 goes into 15 3 times, 5 goes into 30 10 times, okay. But 15 is half of 30, so that's 5 and 1/2, okay. Because 15 doubled is 30. So that's my final answer, reduced, okay. So, and I know I'm kind of covering a lot, but this is supposed to be review, and we're doing it in the first 2 weeks here, just reviewing fractions. Now, I will say to you also, just so you know, it's really nice and helpful if you can do this all by yourself, but you are also, because you're in TS 70, you can start learning how to do this on a calculator, to do these things, adding and subtracting and multiplying and dividing fractions. You can actually start doing them on a calculator, but it's really nice to learn how to do them by hand. All right, let me just take an example. Now I've got number 4 here. I've got 4 3/5 plus 6 and 3/4. Okay. Now, the way I like to do fractions, and it's a little bit different than the gentleman on Khan Academy, Saul Khan's his name. He tends to add things kind of horizontally like this, but I always teach my students to add them what I call vertically. So I'm taking this 4 3/5 and 6 3/4. Okay. And I'll tell you why I teach students to do this. Because when you add, if I had 119 plus 204 plus 17, we add vertically. We don't add horizontally across, from left to right. We add the numbers up vertically, and it becomes kind of easier to make sure you're following all the steps. I just think visually, okay? All right, when you're adding fractions, and these are what's called mixed fractions, because I'm mixing a whole number, 4, with a fraction. So they call the whole thing a mixed fraction, okay? So if you forgot that, you might want to write this over in your notes. Mixed equals something like 2 1/2, okay? I'm mixing a whole with a fraction, and it's called a mixed fraction. All right. I'm going to add, since I'm adding, I highly recommend that you add the whole numbers first and write the answer down nice and big, okay? And the reason is, otherwise you're going to get through working all your math on the fraction, get an answer, and think you're done. And you're going to forget the 10, 6 plus 4 is 10, okay? So I always teach my students, When you're adding fractions, and I'm emphasizing adding, add the whole numbers first. When we get to subtracting, we might have to borrow a little bit. So, all right, in this case, I'm going to change color real quick here. Here's what I would do. I'm going to ask myself, all right, I have 5 and 4 are different denominators. We already talked about the fact that the lowest number they both go into is 20. That's my LCD, lowest common denominator, or lowest common multiple. 4 times 5 is 20, so 3 times 5 is 15. How did the 5 get multiplied into a 20? I multiplied it by 4, so I take 4 and multiply it by the top and get 12. I now have a common denominator, which is 20. I'm going to add my numerator in my denominator, which would be 30 minus 3 is 27. Now, the way I did that was I thought, I know that 15 plus 15 is 30, and 12 is 3 less. So that's how I did that real fast. Now I've got 27 over 20. Uh-oh, what do? I've got a whole number, and I got a mixed number here. That's an improper fraction, excuse me. I've got an improper fraction, okay? What I'm going to do is the same thing I did before. I've taught you. I'm going to change that improper to mix by dividing the denominator into the numerator. 20 goes into it one time. And by the way, it won't always be 1, but the examples I happen to have to be 1. And how many are left over? There's 7 left over. I bring over my denominator here, okay, my 20. Now, here's where some students make a mistake. They think, I'm all finished, yay, moving on to the next problem. What about this 10 over here, okay? Don't forget the 10. That's the whole number, and 1's the whole number. So I'm going to add them together, and I'm going to get a final answer of 11 and 7/20ths, okay? And I always, and I really encourage you to do this, because often they'll say, your teacher will say, reduce all your answers, okay? I always ask myself, can I reduce 7 over 20? No, I can't. Nothing goes into 7 that also goes into 20, and 7 doesn't go into 20 cleanly, okay? All right, I think that's enough for this page for adding, okay? For the sake of time, I'm going to move on to some subtracting, okay? All right, the basic rule of subtraction, if we go a little bit faster now, is the same rule, okay? So if I wrote a little note at the top that says same rule, okay? Which is, it's the exact same rule. I can't subtract until I have a common denominator. In the case of number 1 here, I have 9 and 9. So I'm going to bring down my 9. Okay. Now, instead of adding my numerators, 2 and 5, I'm going to subtract. 2 from 5 is 3. This is a good example of an answer where I probably should ask myself, can I reduce that? Yes, I can. 3 goes into itself once. 3 goes into 9 3 times. That's my final answer, okay? All right. So any fractions that they give you the common denominator, you might be ready to subtract, okay? All right. Now, this next example is I've got 5/6 minus 1/3. All right. In this case, I look at my denominators, just like I did with my adding, and I ask myself, what is the lowest number that both 6 and 3 here both go into? Well, if you're thinking it's like 18 or 12 or something, don't forget that 6 is also is actually the lowest number that they both go into, okay? And why is that? Because 6 goes into itself once, and 3 goes into it. 3 became 6 by multiplying by 2, so 1 times 2 is 2. 6 became 6 by multiplying by 1. 1 times 6 is 6. So 1 times 5 is 5. Now I have the same denominators, so I'm going to bring down my denominator. I'm going to subtract my numerators. 2 from 5 is 3. Okay. And I'm looking at my answer and I'm asking myself, can I reduce that? And yeah, oh yeah, I can. 3 goes into itself once and it goes into 6 twice. There's my final reduced answer. Okay. All right. The next one I'll do a little bit faster. Now, I want you might want to write yourself a little note here. Look down here. If I give you the example, what if you had 17, or let's say 37 minus 9, okay? We learned back when we were subtracting that you can't subtract a larger number from a greater number when we're subtracting. We would borrow and make this a 2 and bring over this 1, make it a 17. That's how we would do that, okay? And then this would be an 8 and nothing, so it's 28. All right, that's what we do when we're subtracting a larger number from a larger number above, okay? Always when you're looking at subtraction, ask yourself, is the fraction on top larger? 5 over 7 is more than half, okay? That's half of 7 is 3.5. 5 over 7 is more than half. And then this is a half. So this is less. I can subtract without having to borrow, okay? It's just really important point. And since I'm not going to have to borrow from the 9, I might as well do my whole numbers first. 3 from 9 is 6. And notice I'm going to make it nice and big. Yelling at me, don't forget me, okay? When you finish your answer, okay? Here we go again. We need to get a LCD, I'll call it an LCD here, lowest common denominator, okay? Between 7 and 2. Well, 2 doesn't go into 7 cleanly. If I double 7, which is the greater of the two denominators, to 14, well, there it is. That is the lowest common denominator. All right, so I write 14. I ask, how did 2 become 14? I multiply by 7. So 1 times 7 is 7. How did 7 become 14? I multiply by 2. So 2 times the numerator is 10. Now I have a common denominator. So I'm going to bring down my denominator. And I'm going to subtract 7 from 10, my numerators, and get a 3. And the last question I'm going to ask myself is, can I reduce 3 over 14? I can't. So my final answer is 6 and 3/14. Don't forget to put the 6 right next to it, okay? Just for the sake of clarity, I'm going to take my eraser, okay? Because I don't want you to think this is 63 over 14. But I'm going to take my eraser here and go, all right, this is 6 and 3/14. All right. So that's a little bit about subtracting fractions. It's the same thing. I'm going to move to subtracting and borrowing. Okay, and this is the most complex part of subtracting is when you have to borrow. So the rule is when I see this minus sign, I'm just going to tell you how my brain thinks. In fact, let me just give you a couple seconds to copy down these problems here. You've got 8 1/3 minus 4 3/4 for number 1. And then you've got 8 2/9 minus 4 5/9. I'm not sure why I picked examples that have the same whole numbers, but that's okay. All right, let's talk this through. Here's how my brain works. If this was an addition sign right here in the bottom left here, I would just add up my whole numbers and get a 12 here. Because it's a subtraction problem, because it's a minus sign, the first thing I'm going to do is I'm going to look at this top denominator, or this top fraction, I should say, and I'm going to ask myself, okay, 1/3, that's less than a half. Is this number below it smaller than that? Is it less than that? This is 3/4. This is more than a half. That means that this fraction, this is like I'm doing 7 minus 9. I'm subtracting something greater from something that's less. And what did we have to do? If this was 37, we had to borrow, okay, and bring over 1 and make it a 17. We had to borrow. We'll do the same thing. It's just we'll follow that set of directions. We're going to borrow from the 8 and make it a 7, okay? Now, I can right now, I can subtract because I'm going to borrow. So I can make this a big 3 here, okay? 4 from 7 is a 3. Now, this is where it gets a little bit tricky, but not too tricky. All right. I'm bringing over 1. You know how you brought 1 over here in the bottom example, okay? But I need to pause for a second and pick a new color here on the screen. Let's just pick red here. I need to make sure you all understand something. 2 over 2 is the same thing as 1. Why? Because 2 goes into itself, into 2 one time, okay? 3 over 3, you might want to write this in your notes, equals 1. Anything on top of itself, any number on top of itself as a fraction equals 1, okay? 12 over 12 equals 1. All right, since these are all equal to 1, here's what I'm going to do. Now, watch this really carefully here, guys, okay? I'm adding 1. I'm going to borrow from this 8, makes it 7. I'm bringing 1 over here. But because I'm going to add, and I want the same denominator, because remember, I can't add. The rule is I can't add fractions until I have the same denominator. I'm going to add, because of this 3 here, the version of 1, I'll call it the version of 1 I'm going to do is 3 over 3. Now here's why, because of this 3 right here. Because I'm adding to 1/3. I'm not adding to something with a 4 on the bottom, okay? Now, here's what I'm going to do. 1 plus 3 is 4. And this is my common denominator, 3, 1/3 and 3/3, okay? So it's now 4 over 3. And I'm going to just slide over, if you want to draw yourself a little arrow here, I'm going to slide 3/4 over here, okay? All right. Kind of pausing there, let you catch up. Now I've got 4/3, which is 1 and 1/3. Okay, this is greater than 3/4 now, okay? But I still don't have the same denominator yet. So what I'm going to do is I'm going to go ahead and do the same thing I've been doing for the last 20 minutes. I'm going to ask myself, what's the lowest number that 3 and 4 both go into? And it's 12. So I write 12 equals 12 equals 12 again. How did 4 become 12? I multiplied by 3. So 3 times 3 is 9. How did 3 become 12? I multiplied by 4. 4 times 4 is 16. Now I've got the same denominator. So I can bring it down, add my numerators. 19 plus 6 is 25. Okay. All right. That's 16 plus 9, but I reversed the numbers because it was just easier to do that in my head. All right. This here is what's called an improper fraction again. It won't always be, but in the examples we have tonight, they are. I'm going to ask, does 12 go into 25 how many times? 2 times, okay? Because 12 times 2 is 24. And that's the difference between 24 and 25 is 1, if I subtracted it. And 12. Now, so I just brought my denominator over here, okay? Now, this again is where it's so important that why we did this first right here. And we wrote it kind of big, okay? We got a 3 over here, and then we got a 2 and 112. My real final answer should be 3 plus 2 is 5 and 112.
Mr. Langley, can I ask a question?
Absolutely. Go just a second. Let me just pause my recording if you don't mind, okay? I'll just pause the recording. Okay, one of my brilliant students pointed out to me that I made a mistake here. So I'm going to clarify. I'm going to fix it. The mistake I made here was I had my numerators 9 and 16 and I added them. I should have subtracted them. And thank you for pointing that out. Okay, I really appreciate that. Math is hard enough without the teacher messing up, right? Okay, so 9 from 16 is 7. Okay, that made it easier. So I've got 7/12. And so what my final answer should be here is, if I just take my eraser here, I'm just going to erase this real fast, is I've got that 3 there, okay, that I mentioned to you before. I've got this 3 right here. I'm just going to bring it over in 3 and 7/12. And the last thing I always ask myself is, can I reduce this 7/12? No, I can't. Okay. All right. The next one I'm going to do just kind of fast, but maybe you don't even have to copy it down, but you can just watch it. This is my thinking. Oh, it says minus here. I got to look at this top fraction. Is it 2/9 is less than 5/9? I'm going to have to borrow. Make this a 7. At this point, I can go ahead and subtract and get a nice big 3 here. Happens to be again. I'm going to add the version of 1 that I'm going to bring over is going to be 9 over 9 because this 9 right here, okay? I'm going to add them up. 2 plus 9 is 11. Since I have the same denominator, I just bring it over here. And I'm going to slide over my 5 9s. 5 over 9. Now this one's a little bit easier because I have the same denominator now. So I'll bring down my denominator and I won't make the same mistake twice. 5 from 11 is 6. Okay. And then some people would go, okay, I'm going to bring over my 3 now. I'm going to bring this 3 over here. Just draw a little arrow. 3 and 6 ninths. Last question you always ask yourself, can I reduce? Oh, yes, I can. 6 ninths reduces. So my final answer is 3. And then 3 goes into 6 once, and it goes into 9 3 times. There's my final answer. Okay? All right, for the sake of time, I'm going to move on here because I've got some more ground to cover here. Key terms here. Tell you what, I'm not going to spend time talking about these. I'm going to email this slideshow to you, okay? But you might want in your notes, write these down for story problems. These are some key terms that you'll want to have down in your notes that really do help you. When you look at the last sentence of a story problem, when you look at that last sentence, look for these kind of key terms and they hint at what you're supposed to do next in the problem. So again, don't worry about copying them all down right now. I'm going to email this to you. All right. Let's move on to multiplying fractions, okay? And I'm going to just kind of jump in right away here for the sake of time because I've got to cover multiplying and dividing here. So when you multiply fractions, and I'll be honest with you, multiplying and dividing fractions is easier than adding and subtracting, okay? And you're about to see why. In the first example I have here on my page here, I've got 3/5, excuse me, 1/2 times 3/5, okay? I can just multiply straight across. 1 times 3 is 3. 2 times 5 is 10. And then the last question I ask myself is, can I reduce? Okay. So what I did was I multiplied straight across. If I'll draw a little arrow here, just to kind of remind you that that's what I did is I multiplied straight across. Okay. All right. On the next example, okay, again, real simple. I've got 5/7 times 2 ninths. I'm going to multiply straight across. 5 times 2 is 10. And 9 times 7 is 63. Okay. And the last question I would ask myself is, can I reduce? I don't think you can. I think that's about as low as it'll get. All right. What do you do if you have 3 fractions? Okay, we're going to talk about this. So let me give you a few seconds to copy down these 3 fractions. And again, if this feels rushed tonight, just know it's meant as a review that you're supposed to have kind of had this before. However, you have the opportunity to slow down this video, watch as many times as you need, watch my videos from Khan Academy that I put in my Canvas class, and just really kind of digest it at your own pace, okay? All right, here's how I would do number 3. I would multiply the top numbers across. I would go 3 times 1 is 3. And I take that answer, 3, and multiply it by 3, and I get 9. Now, watch how I multiply the bottom numbers. 5 times 2 is 10. That answer times 4 is 40. And I don't think 9/40 reduces. Okay, so I just multiplied straight across. 5 times 2 is 10. Take the answer and multiply it by the next number, 40. All right, let's do a couple a little bit more complex than that. But before we do, I want to talk to you about canceling, okay? So I'm going to give you a moment to copy this down here, this thing called canceling. And you can just write canceling. And some of you, this was a point in math where you went, I hate canceling. I remember that it was confusing. And why do we have to cancel? And isn't it just an extra hassle? It's actually not a hassle. And I'm going to tell you why. Because if you were taking a test and you had to multiply these number 3 down here at the bottom, and you got some big number over some other huge number that's, this is like 100 and something over 200 and something, and then, but we're supposed to reduce your answers to lowest terms, you're going to get this 300, 100 and something, yeah, 63 times 5. Yeah, you're going to have numbers in the hundreds, and you're supposed to figure out how to reduce that. That's going to take a long time. Cross canceling is your friend. Essentially, what it means is reducing before you multiply, so you don't have to when it gets harder. Okay. All right. Let me show you the example. You can cross cancel any number on top. I'm going to write this down. Anything on top with anything on the bottom. Okay. All right. Anything on bottom. You can cross cancel anything on top. So for instance, if I had two fourths times, let's say 3/6, okay, I could cross cancel a number on top, like 2 with 6. 2 goes into itself once, and 2 goes into 6 3 times. I could do it this way, but I also could go straight up and down, because 2, that's a number on top, and fourth, that reduces down, and so these two reduce down, okay? But the rule for cross canceling is you can do anything on top with anything on bottom, but you can't go straight across. So to reduce, okay? So here's how I would do number 1. I look at my numbers and I go, oh, I recognize 2 and 4. There's something that goes into both of these. These can be reduced or canceled. So I'm going to cancel 2. I'm going to cross it out. You should too. I'm going to go 2 goes into itself once, and I'm going to cross out the 4 and go 2 goes into 4 2 times. Then I'm going to look at the other two numbers. No, there's nothing that reduces or cancels here. So I'm going to multiply 1 times 3 is 3. And 5 times 2 is 10. And again, I'm going to ask myself, can I reduce that? No. All right. Hopefully by now you might be able to figure out how to do number 2 here. Is there something that goes into any number on top with any number on bottom? Yeah. Watch how I do this, okay? I got 4/5 times 1/6. Giving you a moment to write that down. I know that 2 goes into both these numbers. 2 goes into 4 2 times, and 2 goes into 6 3 times. Now, I want to really encourage you, cancel it, draw a line through it. Otherwise, sometimes you'll get confused as to what you're supposed to multiply when you get to the end. Now I'm going to multiply across. 2 times 1 equals 2. And 3 times 5 is 15. Okay. And again, I look at that and ask, can I reduce that? No. All right. Number 3 is a good example why it's a good idea to cross cancel. So if you write down 7/8 times 9/14 times 5/6, okay, I don't want to have a big, huge number on top of another bigger, huger number and try to figure out how to reduce this. So my eyes look at any numbers on top with any numbers on bottom. And here's what I see first. 7 and 14 jumps out at my brain, okay? 7 cancels with itself once, and 7 goes into 14 twice. All right. Then the next thing I happen to see is I see 9 and 6 here. And I know that 3 goes into both of these. 3 goes into 9 3 times. 3 goes into 6 twice. Then I look some more. Is there anything else I can cross cancel? 5 with anything on above? No, it doesn't look like it. Okay. Now, somebody might ask the question, hey, teacher, is it possible to cross cancel twice? Like, let's say that this was a 9 down here in the bottom left corner, and I had cross canceled these other things and I got a 3 up here. Could I now cross cancel this 3 with 9 if this was a 9? The answer is yes. Sometimes you can cross cancel more than once. Okay, you're just looking at numbers on the top and asking, can they cancel out with anything on bottom? Nothing can, so I'm going to multiply straight across. 1 times 3 is 3, times 5 is 15. 8 times 2 is 16, times 2 is 32. And I don't think that reduces. Yeah, wait a minute. I think it does. No, it doesn't. It doesn't. Nothing goes into both of these. All right, I'm going to jump over number 4 and do it real fast. I'm looking at these and my brain goes right away. I go, oh, this is perfect. This is awesome. 5 goes into itself once. 5 goes into 25 5 times. 11 goes into itself once. And 11 goes into 22 twice. I've got an answer of 2 over 5 real fast. See how much time that saved me? Look what I'd had big numbers to reduce if I didn't do that. Okay. So that's called canceling before you multiply. Let's jump into some mixed fractions, okay, and talk about these, and then we'll talk about dividing here. I'm going to show you how to multiply mixed fractions. So go ahead and write down the first example here, 4.5 times 5 6. Here's the rule. You have to change them to, you have to have you got to change the mixed to improper before you can multiply them, okay? And here's how you do it. This mixed fraction right here, 4.5 here, okay? To change it to improper, I multiply the bottom number, 2 times the whole number, and get 8 and add the numerator, 9. 2 times 4 is 8, plus 1 is 9. So this is now 9 over 6 times 5 over 6. All I did was I just brought over the 5 over 6 here, okay? Okay. So I turned my mixed fraction here into an improper. From there, it becomes kind of easier to do because now I can go, okay, yeah, I can cross cancel these. 3 goes into 2, or 3 goes into 6 twice. 3 goes into 9 3 times. And I don't think I can cross cancel anything else. Yeah, actually, technically I could. Do you guys see where? Okay, hopefully maybe somebody sees it. Okay, look at 3 and 6. This is an example. 3 goes into itself once, 3 goes into 6 twice. Now I'm going to multiply 1 times 5 and get a 5. 2 times 2 is a 4. That is improper. Change it to mixed. 4 goes into it, 5 one time, there's 1 left over, and 4 stays as the denominator. Okay, so that's an example where you could cross cancel actually twice there. Okay, I'm going to do one more because I want to make sure I leave myself time for division here. So I'm going to jump over here to let's just do number 4 here at the top here. Okay, this is 6 2/3 times 3 3/4. Those are mixed fractions. I got to change them to improper first. Here's how. I take my denominator, multiply it by the whole number. 3 times 6 is 18. Then I add my numerator, 19, 20. This becomes 20 over 3 times. Let's look at the next number here. 3 times 4 is 12, 13, 14, 15 over 4. Now I can do some cross canceling with that one here. I can go, yep, these cancel and these cancel. Okay. 4 goes into itself once. 4 goes into 25 times. 3 and 15 cancel. 3 goes into itself once. 3 goes into 15 5 times. My answer is 5 times 5 is 25 over 1, because 1 times 1 is 1. And that's 25. Anything over 1 is itself. So it's 25 is my answer. Okay. All right. That's multiplied mix. And again, I want to say this for the third time. If this feels rushed, it's meant as a review. Listen to the recording as many times as you want. You'll get a chance to practice with your homework. And we are moving out of this into letting you use your calculator as well this quarter. You can go to YouTube and look for a little video on how to use a calculator, and it'll show you. Or you can just say, hey, can you send me a video? And I'll send you a link to a video showing how to use a calculator to do fractions, okay? But again, for now, for this class, we're just reviewing how to do it by hand, and it's nice if you can for the homework and for your quiz. All right, so we got a rule here that hopefully you've started copying down, that when we divide fractions, The rule is we have to invert the fraction to the right of the division sign and then multiply. Or another way to put it, maybe you heard this before, is you got to multiply the first fraction by the reciprocal, which means the reverse of the one on the right, the one you're dividing into it. Okay. That is the rule, is you got to flip the second fraction, the one on the right, upside down and then multiply. Now, that's not too hard because multiplying in general is easier than adding and subtracting fractions. So in my example that I've got here on the screen, I've got 1/2 divided by 1/8. Okay. So I'm going to rewrite the problem as 1/2 times the reciprocal here. The reciprocal of 1/8 is the reverse of it. So if you wanted to know, just really clarify this, okay? A reciprocal. If the reciprocal of 1/2 equals 2/1, it's the reverse of it. The reciprocal of 2/3 equals 3/2. Okay, it's just you're flipping it upside down. Okay, so in the case of 1/2 times the reverse of 1/8 is 8/1. Okay, now I can multiply, but these cross cancel. So I'd probably go, oh yeah, 2 goes into itself once, and 2 goes into 8 4 times. Now I'm going to multiply straight across. 1 times 4 is 4. 1 times 1 is 1. This answer is 4. Okay. Let's do number 2. 3/4 divided by 5/8. Keep the first number the same. This is called a dividend. It's what's being divided into, dividend, and this one on the right is the divisor. We're dividing it into, so it's the divisor that we have to flip upside down. Okay, the number we're dividing into something else is always the number that gets flipped upside down. 3/4 stays the same times the reciprocal of 5/8 is 8/5. Now I can just do can I cross cancel? Oh yeah. 4 goes into itself once and into 8 twice. Now I multiply straight across and I've got 6/5. 1 times 5 is 5. 2 times 3 is 6. That's improper because that's bigger than that. 6 is greater than 5. 5 goes into 6 one time. There's 1 left over and I bring the 5 over. There's my answer. Okay. That's called, that's the basic rule of division. Okay. All right. We've got about 7 or 8 minutes here. Let's do this. I only need to show you one of these. What do you do if you have a whole number in a division problem or even in a multiplication problem? Okay. So I'm going to just show you the rule. If I had 5 times 2/3, okay, for instance, okay, all you got to do is to simplify it in your mind is go like this, put the whole number over 1, and then it starts making sense. Oh, this is 5 times 2 is 10 over 3, okay, which equals 3 1/3. Okay. It's the same in division. Okay. So if they give you a whole number and ask you to either multiply it or to divide, what you're going to do is just put it over 1 like that. Okay. In the second example, just put 8/1. In the third example, just put 2/1. Now I'm going to go ahead and proceed like I just taught you. 3/1 times the reciprocal of the divisor, I'm dividing 3/4 into 3/1, is 4/3. These cross cancel to 1 and 1. I've got an answer of 4. Okay. So that's how you do whole numbers. All right. I'm going to try to, let's see here. Let me try to move on here. Okay. When you divide with mixed numbers, it's the same thing as it is with multiplication of mixed numbers. You got to turn them into an improper fraction first. So I'll give you a few seconds to copy down 2.5 divided by 1/4. Okay. That's better. All right, so here's what I'm going to do with my 2.5. I'm going to write it underneath here so it's maybe a little easier to see here. That's a mixed fraction. I'm going to change it to improper. Here's how I do it. I take the denominator times the whole number and add the numerator. 2 times 2 is 4, plus 1 is 5 over 2 times, what's the reciprocal of 1/4? It's 4 over 1. All right, I'm just going to go ahead and multiply. I could cross cancel, but for the sake of time, this is 20. 5 times 4 is 20 over 2, which equals 10 here, okay? All right, so that's how you divide fractions that are, if you have mixed fractions there. You're going to do the same thing you did with multiplying. You're going to turn the mixed fraction into an improper fraction. Like, let me show you this number 4 over here. If you want to write this down, 5 2/3 divided by 1 8/9. Okay. I would go 3 times 5 is 15, 16, 17 over 3. I'm just going to write it like this, divided by, this is 9. 9 times 1 is 9, plus 8 is 17 over 9. Now, I'm going to take that and go, first number stays the same, 17 over 3 times the reciprocal, which makes this 9 over 17, which makes this cross-canceling heaven. Okay, I'll show you why. I flipped this upside down. 17 over 9 became 9 over 17. And then this cancels. This becomes 1. This goes into itself once and 3. That gives me an answer of thrice. Okay, so that's dividing mixed numbers. And again, I kind of went through that a little bit quickly, but I think it's the same principle as multiplying mixed fractions. So once you got the first one, yeah, that's it. That's all we needed. Hey, we finished with 4 minutes to go. That's awesome. All right, here's what I'm going to do. I'm going to stop my recording, and so let's do this for a second.